Okay, while I'm calling for scores, I'd like you to just do the starter question here. I'll hand this out right now. And I've got, I think, maybe 6 or 7 people haven't turned in the disclosure. That is worth points. It's an easy way. Have it in by, let's say, tomorrow, and I won't count it as late. So this is 2.3. So just a score out of 5. Let's see. Nate. Susan. Alyssa. Josh. JC. Amanda. Charles. Shelby. Alex. Let's see. Caitlin. Kirsten. Colin. Tatum. Ira. John. Kylie. Josh. You go by Josh or Joshua? Joshua, right? Either one? Okay. Kang. Chase. Shane. Samantha. Tokilupe. And Max. Okay. All right. Please make sure your name is on that. Pass that all the way to the front. And if they could land on these corners right up here, so pass them all the way up. I will do this occasionally. If we trade papers and correct, sometimes I'll just take the score. Sometimes I want to see your work and that sort of thing. So go ahead and pass them up. They should land on these corners up here. I want all these. I'll look at these and then I'll hand these back tomorrow. Okay? So please make sure you're showing your work. Make sure it's clear so that when I look at it or somebody else looks at it, they can see what's going on. And please make sure you're honest. I also noticed some of you printed off the graph paper from the website and used that to graph those. That's great. That's always a good resource. Okay. Have I got them all? Because if you called a score and I don't have it up here, it turns into a 0. Okay? All right. All right. Again, a lot of this is going to be review for the first little bit. That should be kind of comfortable. A good way to get things started, get a good grade, and all that sort of stuff. So the first question is, what is the distance formula? Raise your hand if you can tell us what the distance formula is. Distance formula. John?
D equals the big red can thing.
Big radical. Okay.
Right.
Big square root. Yep.
And then it's the x1 minus x2.
Okay. It doesn't matter. It doesn't matter, but we normally do x2 minus x1 with slopes, so we're going to keep it that way here just for uniformity. And then what?
Squared plus y2 minus y1 squared.
Okay. So it's the difference in the x's squared plus the difference in the y's squared. If you did x1 minus x2, it wouldn't really matter because it would find the difference between the two of them, and then it's going to square it. What happens every time you square something? Yeah, it ends up positive anyway. So if this was a -4 or a +4, either one, when you square it, it's going to end up being 16. Okay? All right. Midpoint formula. Anybody remember the midpoint formula? Yeah. Okay, I'll go with that. x2 plus x1. Now, it doesn't really matter what order you put them in because you're going to add them together, but I'll put it this way just for uniformity. Okay. The midpoint formula can actually be thought of as, I like to call it the average point. The midpoint is the average point. And everybody knows how to average two things. You add them up and you divide by 2, right? So if we're finding the midpoint of 2 points, we're finding the average of 2 points. So we add the x coordinates together, divide by 2, add the y coordinates to divide by 2, and there we go. Okay. And then it says find the distance between these points and find the midpoint. So let's find the distance. The distance would be big square root. So I'm going to do x2, -1, minus x1. So that's going to be minus a -4. So that's going to be a +4 quantity squared. And then y2, that's a 2, minus, let's see, y1 is going to be minus -2. So that's going to be a +2 quantity squared. So this is Well, let's see. This is positive 3 squared, right? So this is going to be 9. This is positive 4 squared, so that's going to be 16. So I get the square root of square root of 25, right? And that is 5. So the distance between those 2 points is 5. And now let's find the midpoint. The midpoint is just going to be literally add the coordinates together. Negative 4 plus negative 1 over 2, and negative 2 plus 2 divided by 2. So let's see what we get here. Let's see, negative 4 plus negative 1, that's just going to be a minus 1, right? So that's going to be negative 5 divided by 2, so that's negative 5 halves. It's okay to leave that as an improper fraction. And what about the y-coordinate? 0 over 2. Remember, it's not a problem having a 0 on the top. It's not a problem having a 0 in the numerator. It's a problem having 0 in the denominator. So this is negative 5 halves comma 0. Okay? Any questions? Okay, raise your hand if you were in 1010 last semester. Good. This is going to be pretty easy then, because this is very, very similar. Okay, they cover circles in 1010, and then they also briefly touch on them in 1050 because we use equations for circles quite a bit. Okay, it's important to remember that all you need to know about a circle is how big it is. Okay, in other words, what's the radius? You've got to know what the radius is, and then the other thing is where it is. And we refer to that, or we call that, the center. So if you know the center and the radius of a circle, you know everything there is to know about that circle. Okay? So you'll remember this from Math 1010. Okay, if you saw these type of notes, we can actually come up with the equation for the standard form of a circle, a nice graph-friendly form of a circle. And here's how we do it. We say, well, let's put the center right here. Okay, let's put the center at h comma k. And then remember, the definition of a circle is all the points that are equidistant from that point. So if I go out here, say this far, to that point right there, x comma y, let's say that point is on the circle. Well, any point that's that far from the center is going to be on the circle. That's why it looks like that. Okay? So this distance right here, whoops, let me put it up here. This distance is r. Well, if we set this up using the distance formula, we know for a fact that r has got to be the difference between these x coordinates. So that would be x minus h. This is like the x2. This is like the x1 quantity squared. And then this is like the y2, and this is like the y1. So we'll find the difference between the two of those. So that's going to be y minus k quantity squared. So that's just the distance formula. All we're doing is we're finding the distance between xy and hk, between this point right here and this point right here. That's it. That's all we're doing. And it's just using the distance formula that we used up above. Okay? Any questions there? Well, the problem is we don't normally like things that look this ugly. Okay? I don't like things that look that ugly, and I would rather work with a square than a square root. Square roots tend to be a little bit difficult. Remember, they're one of those functions that have domain issues. You can't take square roots of negatives and stuff like that. So what we do to this problem right here is we say, look, this is an equation. Let's make this equation look a little better. As long as I do the same thing to both sides of an equation, I'm doing an illegal algebraic move. It doesn't change anything here. So I'm going to square this side, and I'm going to square this side. So this is r squared equals x minus h quantity squared, y minus k quantity squared. And that right there, with a little adjustment, is what we call the standard form of the equation of a circle. And the nice thing about it is we can look at it and it tells us everything we need to know. So let's fill this in. This is x minus h quantity squared. This is y minus k quantity squared, and it equals r squared. And if you look at that, it tells us everything we need. Remember, you only need two things, two pieces of information about a circle. You need to know where it is, what's the center, and you need to know how big it is, what's the radius. Okay? The center of this circle is hk, and the radius is r. And you can look at it and you can tell what it is. Okay? And the simplest type of equation for a circle is this right here. Because you didn't add anything to x, and you didn't add anything or subtract anything from y, that means the center is at the origin. Okay, so that's the easiest type. So let's take a look at this example right here. So this is x squared plus y squared equals 25. So that means the center of this circle is at 0, 0. Because if I had to write it, I could write it like this. X minus 0 quantity squared, y minus 0 quantity squared. And 25, it's got to be r squared, so it would be like 5 squared. So the center is 0, 0, and what's the radius? Radius is 5. Okay? So the center's here, and then I just go 5 units in each direction to get a point on the circle. And then I just draw it as nicely as I can. And even if I made a mess up like this and had it look like that, and I said, hey, that's still a circle to me, as long as I've got the center and the radius labeled, that's good enough. Okay? Now, clearly, I'd want to do better work than that, so. Everybody good there? Okay. All right, let's do one that's slightly more difficult. What's the center? Don't say anything out loud, just write it down. What's the center on this one, and what's the radius? We need to know the center and the radius. Remember, the formula is right here. This one has a center at h, comma, k, and a radius of r. What's the trick here? What's the x coordinate? Okay, it's whatever the number is with the x, you just do the opposite of that. Okay, so this is going to be -5, comma, 1. And the radius is, okay, it's going to be the square root of 18, which from 10, you remember how to simplify that? That's going to be 3 times 3 times 2. So the best way to write the radius would be pair of 3s. 3 radical 2. Now I'm also going to do this. Let's figure out roughly what that is. Because if somebody said to me, hey, how long do I need to make this board? And somebody said 3 radical 2 feet. So thanks a lot. Okay? So grab your calculator and let's type in 3 square root of 2. So we know roughly what that is. It's a little over 4. Okay? So we're going to write about 4.2. So the center is going to be -5, 1. So we're going to be right here. And then we're going to go about 4 units in each direction. So I'm going to go over to here, up to here, over to here, and down to here. And as long as I've indicated what the center of the circle is and the radius of the circle is, then that ought to be good enough. Okay, are there any questions? Okay, let's flip the page over then. Sure, there's nothing on the first page. I'll review. This is pretty easy. Okay, all right. So just a quick reminder of what goes on here. We'll talk about why it works the way it does. Everybody from 1010, you know what this graph looks like. You know how to graph a parabola. What does this do to the graph? It actually moves it to the left 3 units. Okay? Okay, now you'd think that adding 3 units to the x would slide it to the right 3 units, right? Because if you add 3 in the x direction, that would be right 3. Can anybody remind us why it moves it to the left? Okay, it makes the graph 3 units sooner. Okay? So instead of coming down and hitting the vertex at the origin, it hits at -3 because it makes it 3 units sooner. Okay? So instead of doing this, it does this and makes it 3 units sooner than it normally does. Okay? Any questions there? So you can apply the same logic to this. The reason this has a center at 4, -2 is because this slows it down in the x direction. It makes it 4 units later, so it makes it at 4 rather than at 0, rather than at the origin. Okay? And it makes this one 2 units sooner, so it moves it down in the y direction. Okay? That's the logic for why it works the way it does. Okay? But this has a center of 4, 2, and what's the radius? Radius is still 3. Okay, so whatever the square root of that number is. Okay? So if you're given an equation that's already in that form, it's really easy to look at it and say what the center is, what the radius is, and then graph it. Okay? There are some problems that are a little bit more difficult, so let's take a look at those. We want to write the equation of a circle in standard form whose radius and center are given. So if they give us h and k, if it's centered at the origin, how do I start writing the equation? X squared plus y squared equals r squared. What's r in this case? 9. So what number do I write here? 81. Okay, that's it. Does this one look, yeah?
So if the center is 0, then you don't have to write parentheses.
No.
X squared plus y.
No, because it would be a little silly to write this. It wouldn't be wrong. It's just a little silly. Okay, just a little redundant. Although I do kind of like this because you can look at it and everybody, I mean, you could bring somebody in here and they'd say, you know, what's the number that goes with the x? Well, it's 0. What's the number that goes with the y? You can see the origin right there, if you want to think of it that way. Anything else? Good question. Okay, is this one harder or easier? In some ways harder. This looks really awful, doesn't it? Okay, but it's not. So we're going to write x minus 5 quantity squared, y minus 6, so that's just going to be a plus 6. Why bother writing that other? And then this is going to be r squared. Well, what happens if you square the square root of 11? You get 11. So that's actually pretty easy in that case. Okay. Any questions? Alrighty, we've got a couple more problems to go here. Here's the assignment at the end. You'll notice you've only got about 10 problems on the assignment today, so it should be pretty easy. This is going to be due on Friday, but here's where it gets a little more difficult. Okay, if you want to, so I use this phrase. I call this a very graph-friendly form because you can look at it and you can know how to graph it. You can look at it and tell what the center is. You can tell what the radius is. Take a look at this guy right here. Can you look at it and tell what the center and radius are? Nope. Because what this relies on, you'll notice that in every single case we've had a perfect square with x and a perfect square with y. Here they are here. And here's a perfect square with x and a perfect square with y. We don't have that in this case. The squares and the x's and all that sort of stuff, they're all kind of mixed up. It's not in the graph-friendly form. Does anybody remember how to deal with this? Yeah. Very good. We group the x's and the y's, so I'm going to group the x's together. So there's an x squared plus a 6x. I'm going to leave a little space. I'm hoping somebody can tell us why I'm going to do that. Here's a y squared minus a 4y, and I'm going to move the negative 15 to the other side, so that's going to be a positive 15. Now, Caitlin is right. We do group the x's together and group the y's together. What do we do next? Okay, make it a perfect square. Did somebody say the right word? It's called complete the square. Now we complete the square. Now the process for completing the square is pretty simple. As long as this starts out with a plain old x squared or y squared, we take half of that middle term right there, or half that middle coefficient, I should say. What's half of positive 6? Positive 3. Now I'm going to write the positive 3, and I like circling it. Then I'm going to add the square of that. So if I square this, I get 9. Now if I put 9 over here, see this red 9? If I put 9 over there, that wasn't in the problem to begin with. So I need to compensate by putting a 9 over here. So see how the two of these will kind of balance each other out? Then I'm going to do the same thing here. What's half of negative 4? Negative 2. Okay, I'm going to circle that. I'm going to square it. That's going to be a 4. Negative 2 squared is 4. So I'm going to add 4 on both sides. So see all the red stuff in the equation? The 9 and the 9, those balance each other out. The 4 and the 4, those balance each other out. So now the reason I wrote this down is this is a perfect square of that variable and that number. This is a perfect square of that variable and that number. And it equals, let's see, what do we get here? 28? Okay, now is it in a form where we can look at it and we can tell what the center is? What's the center? Negative 3 comma 2. And the radius is square root of 28. Now square root of 28, let's see, that's a 2 times a 2 times a 7. So I'm going to write that as 2 radical 7, and then I'm going to figure out roughly what that is. It's a little bigger than, it's 5.29. It's about 5.3. And we should know that it's a little bigger than 5 because 28 is a little bigger than 25. 25 is a perfect square. That's an easy one to find. Okay? So if we're going to graph this, we go to -3. Let me make this a little bit bigger. So this is going to be -3, +2. And then I'm going to go about 5 units in each direction. So I'm going to go about to there. I'm going to go about to there, about to there, and let's see, about there. And then I'm just going to make my circle look like that. Mine looks more like a potato, but that's all right. Again, I've got the center and I've got the radius. Okay, any questions? We're good there? Can I slide this over? Okay. Okay, look at the next one. Sometimes people get tripped up by these. This is actually quite a bit easier. Do I have any perfect squares with either x or y? I do. If I collect the x's together, all there is an x squared. If I collect the y's together, get that. So I really haven't changed much, but I don't have a perfect square with y. I still need to make that. So again, I'm going to switch to red. Half of this middle coefficient, -4. Square that, 16. So I can't just add a 16. That red thing is the only number that wasn't there to begin with. So I have changed this side over here. If I've changed this side over here by adding 16, I better add 16 over on this side. And now I'm going to go back here. I have a perfect square with x. And my perfect square with y is a y and a what? -4 quantity squared. That's why I write that number down. Okay, I can keep track of it because I'm going to use it a little bit later. And that equals 16. So the cool part about this is that is in a nice graph-friendly form. What's the center? Okay, we didn't add or subtract anything with the x, so it didn't move left or right. So it's 0, comma, opposite of the number with the y. And what's the radius? Radius is 4. So 0, 4, we're right here. And then I go 4 units in each direction. If that happens, you just make it really fat. Okay? Okay, they didn't always ask you to do stuff like is coming up in 1010. So can I move this down? We've got 2 more problems, I think. Okay. Find the equation of a circle with endpoints of a diameter at 1, 4 and 5, 4. Endpoints of the diameter. Now this one's not too bad. 1, 4, and 5, 4. Those are the endpoints of the diameter. So if this is a diameter right here, then the circle must go like this. Right? Okay. Let's see. You only need 2 things to write the equation of a circle. You only need the center and you need the radius. Where would the center be in comparison with these 2 points? At the midpoint. Okay, it would be right in the middle. Now on this one you can actually eyeball it. Okay, and you can say, well gosh, if this is 1 and this is 5, the middle ought to be 3. Okay, and since they're both 4, okay, it's got to be on that horizontal line of 4. But let me just show you this. The midpoint would be, add the 2 of these together. 1 plus 5 divided by 2. 4 plus 4 divided by 2. So that still puts me at, let's see, that's 6 divided by 2. That's 3. 8 divided by 2, that's going to be 4. So 3, 4. So the center is 3, 4. Okay, now, how would I figure out what the radius is? Okay, you can use the distance formula. If this point right here is 5, comma 4, and this point right here is 3, comma 4. You can use the distance formula to find the distance. So that would be d equals big square root, let's see, 5 minus 3, quantity squared, 4 minus 4, quantity squared. Now that's a little bit silly on this problem, isn't it? Because it's on a straight horizontal line. I mean, don't we know that if it's 4 from here to here, it's got to be 2 from the center to the edge of the circle? Okay, but look, this is going to turn out to be 2. So this is going to be, let's see, that's 0. That's 2 squared, so that's 4. So the radius is 2. And it says find the equation of the circle. There are the two pieces of information that we need. So it's going to be x minus 3 quantity squared, y minus 4 quantity squared equals the radius squared. And what is the radius? 2. We square that, we get 4. So that, you have some problems that are similar to that. Slightly more difficult because they might give you points that are like this. They might say this is the diameter, and then you've got to find the midpoint that way. But I've shown you all the work there. Okay, are there any questions? We're good? Okay. All right, last problem. All right, the standard form of a circle where the radius is 2 and the center is 0, 0. Go ahead and do that. Check with your neighbor. Standard form of a circle, radius is 2, center is 0, 0. So they've given you h and they've given you k. You need to flip back to that other side. If you know h, k, and r, plug them in and you're done. Emily, what is it? X squared plus y squared equals 4. Okay. We don't need to write x minus 0. That's a little bit silly. You can if you want, though. Solve the equation of part A for y and then enter it into a calculator to graph it. So we want to solve this. This is the answer to A. We want to solve this for y. We want to get the y all by itself. So this is just some algebra. This doesn't have anything to do with circles. This is just some algebra. So go ahead and solve that for y. So how do you get y by itself? Move the x squared. How do we move the x squared? Subtract x squared, right? So we'll subtract x squared. So this is going to be y squared equals 4 minus x squared. I like writing the 4 first and then the minus x squared. That kind of keeps the positive to start with. Okay, it doesn't start off with a negative. Everybody okay with that? Is the y by itself yet? It's not. What do we need to do? We need to take the square root. So we'll take the square root of both sides. Now I have y equals the square root of 4 minus x squared. Okay? So did we solve for y? Did we follow the instructions for b? Yes. Okay. So this is what we've got. We're going to take that and we're going to type it into the calculator. So grab your calculator. Okay, remember I said you should check the mode. Make sure everything down here is highlighted. That's usually how we're going to graph it. I also mentioned yesterday that if somebody messes something up, if they can't get things to graph, sometimes those plots will be on. Okay, so I'm going to just clear that off. And I'm just going to literally type this in. Square root 4 minus x squared. Okay, to be technically correct, we ought to close the parentheses. Okay. Are there any questions? Okay, now, most of the time, if you've used these, you've graphed this in a window that goes from -10 to 10. That's called a standard window. So I'm going to hit zoom. The standard window is zoom 6. So if you haven't used the calculator in a while, want to quickly get back to a familiar window, just hit that and you can either arrow down to the 6 or you can literally just type the 6. I'm just going to hit the 6. It's going to graph that. Now, the first thing we notice is it's not very big. So it would be nice to zoom in. The second thing we notice, you can see it a little bit up here. There are two things wrong with this. Does it look like a circle? No, for two reasons. It looks kind of squished, right? Okay, that has to do with the aspect ratio of the screen. Okay, this screen is set up like a kind of like those old school TVs. It's a little wider than it is tall, and yet this is still 20 units in each this direction and 20 units in this direction. So it's a little bit squished. Okay, that's not very good. Okay, the other thing is it doesn't look anything like a circle because it doesn't have a bottom half. Is that all right? So we're going to do two things to fix that. Hit the zoom menu again. Okay, and see this one right here? See zoom decimal? Zoom decimal is a nice small window. It only goes from negative 4.7 to 4.7 and negative 3.1 to 3.1. Now that sounds like a really weird choice. Why would they want to go further in this direction than this direction? Yeah, because that's the shape of the window. And that's how many pixels there are. There are 94 pixels from side to side and 62 from top to bottom. Count them sometime. So I'm going to hit zoom 4. Does that look more like a circle?
Yeah.
Okay, it looks more like a circular shape, but it's still not a circle. Here's the problem. We ignored something algebraically. We put a square root in a problem. When we put the square root in there, what do we have to account for? The positive one and the negative one. So technically there should be a plus or minus in front of that. Well, your calculator can't graph that. So here's how we fix that. We come back here to y equals, and we can do one of two things. Okay, we can type negative square root 4 minus x squared. Is everybody good with that? Hit graph. There's the top half and there's the bottom half. Now, why won't your calculator graph the top half and the bottom half with just one function? Yes?
Because the square root, and then, well, actually, I think the square root just makes it completely positive. Am I right?
Yeah, that's right. And if it did that, would this be a function? It wouldn't pass the vertical line test. Okay? With your calculator in the mode that you're used to working with it, it will only graph functions. It will only graph things that pass the vertical line test. Okay, any questions there?
Would you change the mode
I didn't change the mode. Okay, I did that.
to? Oh,
Okay? All right.
okay.
Good?
Mine has a gap.
Oh, your axes are gone. Bring it up. Bring it up in a minute. I'll show you how to bring your axes back. Okay. Let me show you one more thing. Okay. Rather than do this, if you've already typed in a big ugly mess and all you want to do is just change the sign, just do a vertical flip, because that's essentially what we did, is we flipped it upside down. Then you can do this. Type a negative. Can everybody watch, please? You can't see it very well here, but right here next to the clear button is a button that says vars, right here. There's clear vars. Hit the vars button. Okay, and then go to y vars. So go over here. And the first thing we want is function. And either type the number 1 or hit 1. And here's what it does. It's going to graph the negative of whatever that one was. Does that make sense? So we'll hit graph. There's the top half. And there's the bottom half. Okay? Want to see something cool? No, you don't, but I'll do it anyway. Graphs them at the same time. Okay, by just putting it in. See, you don't think it's cool, do you? It's ridiculous. Okay, I put it in simultaneous mode rather than sequential. So instead of graphing y1, then y2, then y3, and so forth, it graphs them all at the same time, which sometimes is useful. So I'll quit. I'll go back to the home screen. That's it. Have a great day. Tomorrow, bring your calculator and your calculator worksheet. We'll take a few questions from this. The first week starts off pretty slow. Take advantage of it. Get good grades. Develop good habits, all that good stuff.
Yeah, I didn't really know why it was small.
Well, I don't, the problem I'm having is, it's also not showing the axis, but it's not, there's a gap right there.
Okay. So we're gonna go to mode. We're gonna go to format. We're gonna turn the axes on.
Could it be possible that those?
Have you used this? Is this your calculator?
No,
Okay.
I just got it from the office.
There
Okay,
you go.
thank you.
Okay.
Where would I turn in the display?
Oh, I'll take it.
Thank you.
Okay.
I have this for you.
Perfect.
And then yesterday I went home without grabbing a book before I went home, and then
Okay.
I looked at the bottom and saw the
Okay,
homework, so I didn't get it done.
that's fine. Do you have a book now?
Yes, I do.
Okay, you're fine.
So I'll bring it tomorrow.
Thank you. Yep, thanks for telling me.
Thanks.
See ya. See ya.